Welcome to PreMath. In this video, we have got this right triangle ABC, as you can see in this diagram, such that this angle BAC is 15 degrees, and the area of this given right triangle is 1 centimeter square. And we are not supposed to be using calculators at all. And now our task is to calculate the side lengths AB, BC, and AC of this right triangle. Please don't forget to give a thumbs up and subscribe. Please keep in mind that this figure may not be 100% true to the scale. Let's go ahead and get started with the solution. And here's our very first step. Let's recall the triangle sum theorem. The sum of three interior angles in a triangle is always 180 degrees. So therefore, in this given right triangle ABC, the angle of this ACB is going to be 75 degrees. And now let's recall the area of a triangle formula. Area equals to a half times base times height. And in our case, this AB is our base, and this BC is our height. Let's assume the base of this right triangle is x and the height is y. And we know the area of this triangle has been given to us as 1. So let's go ahead and fill in the blanks in this formula. So the area is 1 equals to a half times our base is x and the height is y. And now let's go ahead and multiply both sides by 2 to remove this fraction. So I'm gonna multiply this one by 2 on the left hand side as well. And here we can see 2 and 2 is gone. So therefore our x times y value turns out to be 2. Let me go ahead and call this our equation number 1. And here's our next step. I have connected this point C with this point D, as you can see in this diagram. And as a result, we got this right triangle CBD. And let's assume that this angle is 60 degrees. And we know the sum of angles in a triangle is 180 degrees. We know this is 90 degrees. So therefore, this angle has got to be 30 degrees. And now let's make an observation. We know that this whole angle is 75 degrees and this angle is 60 degrees. So therefore, this remaining angle ACD is going to be 15 degrees. And now let's make an observation. We can see that this angle is 15 degrees and this angle is 15 degrees as well. So therefore, this triangle ADC is going to be an isosceles triangle. So therefore, we conclude that this side length CD is going to be equal to this side length AD. And here's our next step. Let's focus on this right triangle BCD, and we can see that this is our special 30, 60, 90 triangle. And here I have copied down this right triangle BCD over here. And since this is our smallest angle, 30 degrees, so the side opposite to that angle is going to be our smallest leg. And since this 90 degrees is our largest angle, so the side opposite to this angle is going to be our longest leg. So therefore, in such kind of special triangle, the longest leg is twice the smallest leg. If the smallest leg is 1 unit, then the longest leg is going to be 2, and this third leg is going to be square root of 3. Now let me go ahead and multiply all these sides by y across the board. I'm going to multiply this 1 times y, this becomes 2 times y, and this becomes y times square root of 3. And now let's make an observation. We can see our this BC length is 1y, and over here BC length is 1y as well. Then this CD length is going to be 2 times y, and this BD length is going to be y times square root of 3. And now let's make an observation. We can see that this CD length equals to AD length. So therefore this AD length is going to be 2 times y as well. And now let's make an observation. Once again, we can see that this whole AB length is going to be 2y plus y times the square root of 3. Let me go ahead and write down 2y plus y times the square root of 3. And we can also see that this whole AB length is also equal to x. So therefore I can equate this one x equal to 2y plus y times square root of 3. And here we can see y could be factored out. So therefore x could be written as y times 2 plus square root of 3. And now let's recall once again this equation 1. And here I have copied it down, x times y equals to 2. And now let me go ahead and substitute this x for this y times 2 plus square root of 3 over here. So therefore I'm going to replace this x by y times 2 plus square root of 3, and then this times y equals to 2. And here we can see y times y is going to give us y square. So therefore we got, and now let's go ahead and divide both sides by 2 plus square root of 3. This is gone. So therefore y square turns out to be equal to 2 plus square root of 3. And now let's go ahead and rationalize the denominator by multiplying by its conjugate, 2 minus square root of 3 divided by 2 minus square root of 3 as well. As you can see in this next step, I have multiplied out these numerators and the denominators as well. And now let's recall this famous identity, a plus b times a minus b equals to a square minus b square. And we are going to apply it on the denominator. And here I have copied it down, and if we apply this identity, it turns out to be equal to simply 1. So the denominator, if we multiply these ones, turns out to be 1. As you can see in this next step. And now let's go ahead and distribute this 2. So therefore our y square turns out to be 4 minus 2 times square root of 3. And now let me go ahead and tweak this 4. 4 could be written as 3 plus 1. And now let's tweak this 3. 3 could be written as square root of 3 and then whole square. And 1 could be written as 1 square. And now let's recall this famous identity, a minus b whole square equals to a square plus b square minus 2ab. We are going to apply it on the right hand side. So therefore the right hand side is going to become square root of 3 minus 1 whole square, and the left hand side we got y square. And now let's go ahead and take a square root on both sides to undo this square. So therefore this square and square root cancel each other out. Likewise over here they cancel each other out as well. So y value turns out to be simply square root of 3 minus 1. So therefore our this BC length, which is y, turns out to be equal to square root of 3 minus 1. And now let's focus on this equation. X is equal to y times 2 plus square root of 3. And here I have copied it down. And now let's go ahead and replace this y value by this square root of 3 minus 1. As you can see in this next step, I have substituted this y value over here. Now let's go ahead and multiply them by doing the double distribution. So therefore x is going to be equal to 2 times square root of 3 and then plus 3 minus 2 minus square root of 3. And here if we combine the like terms, we are going to get x equal to square root of 3 plus 1. So thus our this AB length, which is represented by x, turns out to be square root of 3 plus 1. So thus our AB length turns out to be square root of 3 plus 1, as you can see over here. And our BC length is square root of 3 minus 1, as you can see over here. And here's our final step. Let's go ahead and calculate this third side length AC now. So therefore we are going to use the Pythagorean theorem. And here's our Pythagorean theorem: a square plus b square equal to c square. Let me call this longest leg as our side c. I'm going to call this side lowercase a and this lowercase b. So let's go ahead and fill in the blanks in this Pythagorean formula. A in our case is square root of 3 plus 1 whole square, and b is square root of 3 minus 1 whole square equal to c square. And now let's recall this famous identity: a plus b whole square could be written as a square plus 2ab plus b square. We are going to apply it on this first one. And as a result, we got 3 plus 2 times square root of 3 plus 1 for this one. And now let's recall another identity: a minus b whole square could be written as a square minus 2ab plus b square. We are going to apply it on this second one. As you can see in this next step, I have took care of this one, and we got this one: 3 minus 2 times square root of 3 plus 1, and that is going to be equal to c square on the right hand side. And now we can see 2 times square root of 3 and minus 2 times square root of 3 is gone. And if we combine the like terms, so therefore c square turns out to be 8. Let's go ahead and undo this square by taking a square root on both sides. So therefore c turns out to be equal to, and we can see that the square root of 8, if we simplify, that is going to be 2 times square root of 2. So therefore c value turns out to be 2 times square root of 2. So thus our AC length turns out to be 2 times square root of 2. And here are our AB, BC and AC lengths. Thanks for watching, and please don't forget to subscribe to my channel for more exciting videos. Bye.